Hi everybody, it's Mrs. Dunn. Today what we're going to do is talk about equations of lines and modeling. Specifically, I want you to learn how to determine the equation of a line. Mostly we're going to be using point-slope form. Then we're going to talk about parallel and perpendicular lines. I want you to know how to determine the slopes of parallel and perpendicular lines, and then given two equations, determine if they are parallel or perpendicular. And lastly, we're going to do a little bit with linear regression. We're not going to get into it too deeply, but I do want you to be able to recognize a scatter plot that can be modeled with a linear function. Okay, so we're going to start with something old and then learn something new. So the something old that we're talking about is slope-intercept form. Remember we did that in a previous screencast. So slope-intercept form is y equals mx plus b, and it's called that because m is the slope and b is the y-intercept. So we're going to apply that to what we have to do today. So the kind of question you're going to see in this section is, a line has a slope of -3/4 and a y-intercept of 0.5. Find an equation of that line. Well, we're going to use slope-intercept form. We know the slope and we know the y-intercept, and we're simply going to plug that into the equation. So the slope m is -3/4 and the y-intercept is 5. Remember, the slope is -3/4, the y-intercept is 5. We just plug those values into the equation. Okay. So now what we have to do is apply this concept to a new kind of question. So we are going to not only find the equation of the line when we know the slope and the y-intercept, we're going to use point-slope form, this new equation, to find the equation of the line when we know the slope in some arbitrary point that is not necessarily the y-intercept. So point-slope form looks like this. Y minus y1 equals m times x minus x1. In this equation, y1 and x1 are the x and y coordinates of the point we're given, and m is the slope. So it's going to be helpful if we look at an example. So find the equation of the line with a slope of -3/4 and it contains the point -4,6. We're going to take these pieces of information and plug them into point-slope form. So the slope is -3/4. I substitute that for m. And not y-intercept, but the point that the line goes through is -4,6. So the x value is -4 and the y value is 6. And I plug that into the equation. So now let's go through and let's simplify this equation. Now, when we're done, our equation is going to be in slope-intercept form. Now watch. The first thing I want you to notice is we have two negatives in this parentheses, so that makes a positive. Then I'm going to distribute the -3/4. So when I distribute -3/4, I get -3/4 x minus 3. See, these 4's cancel. So it's going to be 3 times 1. So that's where we got the -3. Remember, this is negative. And then when I'm all done simplifying it, the equation is y equals -3/4 x plus 3. This is the equation of the line. It has a slope of -3/4 and it goes through the point -4,6. Okay, let's look at another question. Find the equation of a line containing these 2 points. So this time, I'm not told the slope. I'm only told 2 points, but I know how to find the slope. So our strategy is going to be to find the slope using that formula y2 minus y1 over x2 minus x1. And then we're going to use that slope in one of the points to find the equation. Okay, so let's get started. So the slope of the line is what we're going to find first. So I subtract the y values, -4 minus 5, and 2 minus negative 1, which is negative 9 over 3. So the slope is negative 3. Now, I can use either of these 2 points in point slope form. It doesn't matter, you'll get the same answer. I'm just going to use the first one. So I'm going to plug the slope and this point into point slope form. So y minus 5 is equal to negative 3 times x minus negative 1. And now the next series of PowerPoint slides is just going to be me simplifying this expression. Whoops, I went a little too fast there. So first what we did is we substituted this point into the point slope form. And then once again, I have 2 negatives, so that makes a positive. And I distributed negative 3. And then when I'm all done simplifying this, the equation is y equals negative 3x plus 2. Remember, I'm going to add 5 to both sides. All right, I hope that made sense. Okay, now, what we're going to do next is we're going to switch focus and talk about parallel and perpendicular lines. So first of all, parallel lines have the same slope. Let's look at some examples. So for example, if I have the equation of 2 different lines, y equals 2x minus 3 and y equals 2x plus 5, what are the slopes of these lines? Well, the slope is 2 for both of those. Because the slopes are the same, we know those lines are parallel. You know, if I graph that on my graphing calculator, you can see these lines are never going to touch. That's what it means to be parallel. So they have the exact same slope, but they're not exactly the same line. Okay, so what about perpendicular lines? So perpendicular lines have slopes that are opposite and reciprocal. So I want you to look at an example of perpendicular lines, 2 lines that are perpendicular. So these 2 lines are perpendicular to each other. And you'll see that the slope of the first line is 1/3, and the slope of the second line is negative 3. So the reciprocal of 1/3 is negative 3. So these 2 slopes, they're opposite, one's positive, one's negative, and the reciprocals. This is 1/3 and that's negative 3. So they're opposite and reciprocals. Look at the graph of these 2 perpendicular lines. These perpendicular lines are going to intersect and form a right angle. Okay, so let's do what we were doing before, finding the equation of lines, and let's use this new concept of parallel and perpendicular lines. So another type of a question you're going to see in your homework is find an equation of a line that passes through this point, 3, 5, and is parallel to y equals 2/7x plus 1. So think about it. We need to know a point that the line goes through, got it, and we need to know the slope. Well, the slope of the line we want has to be parallel to this line. So parallel lines have the same slope. So we do know the slope. The slope is 2/7, and the point we know is 3/5. So once again, I'm going to use point slope form. Y minus y1 equals m times x minus x1. I put the slope in for 2/7, and I put 3 in for x and 5 in for y. And then I'm just going to simplify this expression. So I get y minus 5 equals 2/7x minus 6/7, and then I'll add 5 to both sides. And I end up with y is equal to 2/7x plus 29 over 7. All right. The last thing I want to do is talk about scatter plots. And we're just going to touch on this briefly. So if I'm given some data, for example, this is the year and the cost in millions of a Super Bowl commercial. So in the year 2000, it cost $2.9 million, and in the year 2015, it cost $4.5 million. So if we were going to plot those on the X and the Y coordinate system, the dots would look something like this. Okay? And so what we want to know is, can this be modeled with a line? So can we draw a line that's going to predict what's going to happen in the future? And the answer would be yes. You can see it's not going to fit perfectly, but this line, this straight line, is pretty close to what these 2 points, all these points are on. That's pretty close to that line. So we would say that this is a scatter plot that can be modeled with a linear function. So the graph does appear to be linear. Now this is an example that is not linear. So here's the data points, which are plotted here. And you can see that this one is increasing at a more rapid pace. And it's not very linear. If I try to draw a line through that, you can see this line does not fit these dots as perfectly as it did before. So we say that this graph is not linear. Okay, that's all there is to it. Email me with any of your questions.